Okay, here we are. We got Chapter 3, Section 4, arc length and sector area. We're going to calculate the arc length and sector area given in radians and the central angles, the radius and central measures. Now, you might think that this is sounding familiar. It's because it is. You've actually done this before. The arc length is the measure along the circumference of the circle. So circumference is the entire distance around the circle. Your arc length is going to be this measurement of like the partial portion of that circle. So you have some sort of angle theta that opens up. This right here is going to be your sector length. Okay. Your arc length from geometry was the theta over 360 times 2 pi r. This right here is the full circumference of a circle. This is representing the fraction circumference. Now, with a little bit of algebra and converting that theta from a degrees to a radians, it's going to work out that the arc length, S, is equal just to your radius times whatever that theta is. But the important part about that is that your theta is put in as a radian degree or something in terms of pi. So if we find the length of the arc but cut off by a central angle of 3 radians in a circle with a radius of 5.4, okay, again, because I know that it's in radians, I can take S is equal to the radius, 5.4 centimeters, times the 3 radians, and my arc length is going to be 5.4 times 3, which is about 16.2 centimeters. Okay, if we're going to find the arc length and the central angles given in degrees, we'll take 130 degrees divided by 360 degrees, and we'll take it 2 pi times the 4 for the radius of that circle. Okay, so a little bit of reducing. Let's see, 13 divided by 36. Okay, this is 0.361111 times 2 pi times 4, and I get a total of about 9.075, so let's go 9.08 inches. Okay, so in degrees, this formula; in radians, this formula. Okay, the minute hands of a clock is 1.5 inches long. Sorry, centimeters long. How far does the tip of the hand move in 20 minutes? Okay, so we need to first find the measurement of this central angle. Well, if this is 20 minutes out of 60 minutes, this is essentially 1/3 of the circle, or 1/3 of 360, and I got the 360 because of the full circle, is 120 degrees. So the measure of the central angle would be 120 degrees, or I could go 120 times pi over 180 and reduce that by 6, 2 pi over 3 radians. Either or. If I were to use radians, I'm just going to find the arc length, S, by taking r times theta. If I were to use the 120, I'd go S is equal to the theta, the 120 over 360, 2 pi r. I kind of like the second one a little bit better, so I'll take the 1.5 times 2 pi over 3, or 3 divided by 3. I think it ends up being pi, or the estimate of pi, 3.1415. Oops, I guess I can't leave the page on Notability. Centimeters. Okay, yeah. Now sector area. Okay, when we're trying to find the sector area of this guy, it's gonna look like the same fraction, but theta over 360, because that's the fractional part of the circle. But now instead of it being 2 pi r, it's going to be pi r squared. And for sector area, I got to cheat real quick. Okay, I forgot the 1/2. But S is equal to 1/2 radius squared times your theta. Okay. So I want to find the sector area. By the way, it is the entire filled in portion of that piece of pie. Okay, I want to find the sector area of this circle. I've got 2.5 radians. So I'm going to go, the sector area is 1/2 2.5 squared and times that theta, which is that should be 10 squared times 2.5. So what, 1/2 times 100 times 2.5. This is going to move the decimal spot a couple, 250 divided by 2, 125 centimeters squared, and squared because it's area. Okay, very similar situation, but now we're given it in degrees. So the sector area is 135 over 360, and that's gonna be times 2, pi 16 squared. Sorry for my chicken scratch there. Okay, so 135 divided by 360 times 16 squared times pi, and I get about 301.59 let's see, feet squared. Don't forget the squared because we are talking about area right now. So again, just make sure you check to see what your angle is being measured in, and you choose the appropriate formula. Okay, so a sector formed by a central angle of 15 degrees has an area of 100. Okay, we're going to work our way backwards. So I know the area is 180. I know since I'm getting 15 degrees, it's going to be the area is equal to the degrees over 360 pi r squared. Theta is going to be 15 over 360 pi r squared. So what I'm going to do is I'm going to make that 15 over 36 into a decimal. And then I'm going to multiply by pi. So 15 divided by 360, okay, times pi. Okay, so I got 180 degrees is equal to 0.130899. As many decimals as you can would be the best. I'm going to clear that out. So 180 divided by that decimal. Okay, get about this. And now to get rid of the square, I'll take the square root of that number. And get about a radius of approximately 37.08. And we were centimeters squared, so now it's just going to be centimeters because we're talking about that linear radius. There you go.